This building consumes enough electricity to power a small city. Every hour, every day, non-stop. It has its own infrastructure, its own cooling system, and its own security parameters. Engineers maintain it around the clock. You'd assume something critical runs inside here. A hospital network, air traffic control, a country's financial system. Could be anything. But it has one job. That question, that one throwaway question, just consume the same electricity as 10 football stadiums running at full power. And you've asked hundreds of them. So, what is actually happening inside that building? Let's go find out. The moment you hit send, your message gets encrypted and fired over HTTPS towards a server. But here's what most people imagine. Your message goes to a computer, that computer thinks, and it replies. That's not even close to what happens. Your request first hits a load balancer. Think of it as a traffic cop standing at a motorway junction. Hundreds of requests are flooding in every single second. And that very load balancer is deciding which lane the question is supposed to go based on where there's capacity. And only after that, your message reaches a GPU, and not one GPU, a cluster of them. The model doesn't read your sentence the way you do. It breaks it into tokens, small chunks of text, and then does something completely absurd in its simplicity. It guesses the next word. Before it guesses though, it runs something called attention. Every token looks at every other token and asks, given everything, what matters most to me? The answer saves the guess. Here's the analogy. Imagine trying to finish someone's sentence, but instead of just remembering last few words, you're weighing every single word they have ever said to you, ever, simultaneously, in about a millisecond. That process, token by token, layer by layer, is what thinking looks like in a language model, repeated across 100 stacked layers, across 100,000 GPUs in under a second. And that's why it needs 10 stadiums of power. Now, these GPUs are generating extraordinary amounts of heat. A single GPU cluster pulls around 120 kilowatts every pack. That's roughly same as running 1200 hair dryers simultaneously in a metal box. So, how do you even cool something like that? You drown it. Yes, you've heard that right. You literally drown it.
Hello, how are you? I am under the water. Please help me. Here too much raining.
Hyperscale data centers are increasingly using liquid immersion cooling. Servers physically submerged special non-conductive fluid. The heat transferred directly into the liquid, cutting the power needed for cooling by around 50%. It looks exactly like GPUs in an aquarium, because that's exactly what it is. In 2026, Microsoft, Google, Amazon, and Oracle combined are on track to spend $700 billion on this infrastructure in a single year. And it's not just the US anymore. Melbourne, Sydney, suburban Australia is also getting these campuses, because the closer the data center is to the user, the lower the latency. Training one frontier model, something like a DeepSeek V4, it takes around 4 weeks across 100,000 GPUs, running flat out before even a single person had chatted to it. Here's something you can do right now. Open DevTools on any AI platform, hit network. Watch where your request actually goes. If you're in Australia, your query typically hits the Sydney node first. Then, depending on the platform, it routes to a full inference cluster on the US West Coast. That's roughly 12,000 kilometers. It goes there and gets processed across thousands of GPUs and then comes back in under 1 second. 1 second. Sometimes even less. I know it gets crazy. Text generation is expensive, but video generation is completely different category. Tools like Sora, Midjourney don't run the same old processes. They use diffusion, which starts with a frame of pure random noise and slowly sculpts into coherent pixels. Each sculpting step requires its own GPU pass. We're talking thousands of GPU seconds per frame. The power cost of one AI video query is roughly around 0.5 kilowatts per hour. And that's the same as boiling your kettle 15 times for one video. And that took like seconds to generate. Multiply that by the number of queries happening right now. Right now. The number gets very hard to sit with. Here's where the story lands. Right now, AI data centers consume around 1 to 2% of global electricity. That sounds manageable. It's alright. By 2027, analysts are already modeling gigawatt scale facilities as a norm. 1 gigawatt. That is the output of a nuclear power plant dedicated to one data center, which is exactly why Microsoft and Google are signing deals with nuclear operators right now. Because renewables can't actually feed fast enough or scale fast enough to feed what's actually being built. This trajectory puts AI somewhere between like 8 to 10% of global electricity consumption. And within a few years, and this is not a footnote, that is a civilization scale infrastructure decision. And it's being largely made without a public conversation. Every time you ask an AI something, a question, an image, a video, that request joins millions of others, all flowing through this machine. Stadiums of power, oceans crossed, GPUs underwater. It's not magic, it's infrastructure. And it's being built faster than most people even realize. So, I want to know what you guys actually think. Is AI worth the grid cost? Or is it a problem that we're seriously not talking about enough? Comment below. I read every single one of them. If this video changed how you see that blinking cursor, hit like. It genuinely helps me. And subscribe. Because in the next video, we're going deep inside the chip that actually makes all of this possible. The GPU itself. I'll see you there.